And so we'll start the comparison. Ignore about the left side code as of now. That is written in C programming. So you're not aware of it. So here you see, as I told you, bubble sort, bigger bubble will always float to the top. Okay. Bigger elements will always end at the end of our list. And how we would do that? What is the second point? We will be comparing adjacent elements. So J, it is pointing to 0. What is the adjacent element? J plus 1. Okay, the next
Yes.
value that is pointing to 1. Now, ignore about all the code part, all the indications. First, compare the adjacent elements 7 and 4. Okay,
Okay.
which one is bigger?
7 is bigger.
7 is bigger. What did I tell you the first point? Bigger bubble will always float to the top. So
Top.
top is end of the list. So 7 is present at the starting or it is present towards the end?
7 is present to starting.
Starting. So what do we need to do? Bigger bubble should float to the top. So we need to move 7 to the place of 4. We need to swap both of them. So here the condition was true. Okay. So condition was true. 7 is greater than 4. So we need to swap them. Okay. 7 and 4 will be swapped.
Okay.
Right. So bigger bubble is floating to the top. That's it. Adjacent elements you have compared. Now you need to continue. You should not stop there. Okay. So you have compared that one. Now you need to continue. You need to move to the next one. Now again, same thing. Adjacent elements. Now I'm taking the positions 1 and 2. The elements inside the positions 1 and 2 are 7 and 5. Now compare them. Which one is bigger?
7.
7 is bigger again. Swap 7. So 7 will float to the top. Bigger bubble floats to the top. Now this comparison is also done. Now I'll compare the next two adjacent elements, that is 7 and 9. Which one is bigger?
9.
9. So 9 is present on the left side or right side? Is it present on top or bottom?
Right side. It's present on the
Right
top. Right?
side.
Yes.
So is there any need for me to change it?
No,
Should I
sir.
swap anything? No, they're correct. They're in correct positions. No, we don't have to change anything.
Anything.
Right? So here the condition will also fail. We'll see the coding part later. So that is fine. So we don't have to change anything. Done. Next.
Okay.
Next one. We have 9 and 8. So which one is bigger?
9 and 8. 9 is bigger.
So we need to swap or not?
We need to swap. We need to swap.
So swap it. 9 will come to the right side again. Okay. Done. Next, that is also done. Now 3, 4 is done. Now we need to compare 4 and 5. Which one is bigger? 9 is bigger. Okay. Again,
We need to
I'll
swap.
fast forward this a little bit. 9 will float to the top. Next, 4 and 5 is done. Now we need to compare 5 and 6. Which one is bigger? 9 is bigger. So again, 9 will float to the top. Okay. Now which one is bigger?
9.
6, 7
Again
are
swap.
bigger. Okay. So 6, 7, 9 is bigger. So again, 9 will swap. 9 will float to the top. Next, last comparison. 9 and 3 we have. Which one is bigger? 9 is bigger.
9 is
So
bigger.
9 and 3 are swapped. Done. So do you have any other values to compare?
Yes, because
Yeah, like I'm asking about 9. You see, we have
for
started
9
from
no need.
0, we have compared up to 8. So the conclusion, the biggest element, okay, it moved to the end of the list. That's it. We don't have any more elements to compare 9 with. So 9 is fixed. What did I tell you? Bigger elements floats to the top. So
Top.
now 9 is fixed. Next time, even if I compare 9 with anything else, it will not change its position. So we don't even have to compare it. So 9 is fixed. We can consider it is done. Now we only have 8 elements in our list. We can say so 0 to 7. So 9 is fixed. That is done. We have sorted it. That is the end of one iteration. Okay. Understood? One
Sure.
iteration. One iteration means executing all the code inside our loop once. If I execute all the code inside my loop once, one element will be sorted.
Sure.
Okay. Now again, I want you to place your hand on okay, the 8th index. I just want you to hide that number. Okay. Your eyes should not see it. Only look up to 7. Okay. Place your hand on the screen.
Yes, sir. Placed.
Yeah. Now you see, now imagine, forget everything else. Forget I didn't even show you the first iteration. Now we are starting freshly again. We are starting from the beginning again. So now you see here, again, we are starting from the beginning. So now the first two elements that you have to compare are 4 and 5. Which one is bigger?
Uh, 5.
Is it
Correct
present
place.
on the right side? Is
Yes,
it
sir.
present on the top? Bigger element is on the top. Okay, so we don't have to change anything. So that is correct. So the loop condition will fail. So it is fine. So will not change it. Now we'll go to the next one. Now next two adjacent elements are 5 and 7. Which one is bigger?
7 only. Correct position,
S-
sir.
7. So correct positions. Do I have to swap it?
No, sir.
No. We'll leave it in the same way. We'll go to the next two adjacent elements for comparison. Now swap it or not?
Sir, the one's given a 5 greater than 7.
Yeah. Yeah, like
But
that will change, you know. Yeah, here. This is the animation, so we change it. So don't worry about the code. You see now, 7 and 8. Which one is greater?
same, no, no need to swap, sir. 8 is
No need to
greater.
swap. So the condition fails. So I press it, then only that red colors and all will come. Okay, done. So now, do we have to swap?
They need to swap, sir. 2 and 8.
Yes. Okay, the condition is true. 8 is greater than 2. So we need to swap them, right?
Right.
Done. Now 8 and 2 are swapped. It's next lot. So should we swap or not?
Sir, yes, sir, we need
Should
to
we
swap.
swap
1
or
and 8.
not?
1 and 8.
Yes. Yes, we have to swap. Very good. So bigger bubble floats to the top, and that floats to the top by comparing adjacent elements. Okay, keep this in mind. Next one. Should we swap or not?
Yes, sir,
Sharon.
we need to swap. 6 and 8.
Yes. Very good. Very good. Bigger bubble floats to the top. Okay, done. Next two adjacent elements. Should we swap or not?
Yes, sir. 3 and 8.
Yes, so we should swap. So now I hope you still have your hand on the screen hiding the last element. Now, if you
Yes, sir.
observe, we have completed the second iteration, and by the end of second iteration, one element is again sorted. Now we don't have any other elements to check 8 with. So 8 is also fixed. From the next time onwards, you don't even have to consider 8. Even if you consider it, it will not change its position because that is the second largest element. It will stay there only. We did that in the entire iteration. We did that. So if we keep on comparing the sorted elements, for this 9 elements list, it is very simple. We can perform 9 more iterations. But imagine you have 10,000 elements to sort.
God.
And every time, if you keep on comparing the sorted elements as well, okay, minimum, at least for you to imagine, we have to perform 10,000 more comparisons, which is a huge number. We don't have to do it. There is no point in doing it. Okay. So we will not consider to check okay, after 6 now. We will only check it up to 6 from the next time. So that is how we are going to set those limits and all, right? So remove the hand. Now, which elements are fixed? 8 and
9.
9 are fixed. So by the end of second iteration, this is what you will get. Now, third iteration. Can you tell me what happens in third iteration?
Third iteration, same thing. Like 4, 5 won't
So
swap.
can you tell me the output of the third iteration? Can you tell me the number? Take that paper, tell me how values will be swapped. End result. This is the end result of second iteration that you're seeing on screen. Okay. I want you to tell the output of third iteration.
Third iteration, like for 0 and 1, it will remain
No, no, no,
same.
no. Just tell me the entire. No, you do it on a piece of paper. Tell me the number. Sir, 4, 5, 7, 2, 1, 6, 3, 8, 9. This is second iteration. So third iteration, A, B, C, D, something. Tell me in that way.
Okay, okay. Sir, for third iteration, it's like, 1 second, I'll just do it 1 second.
Yeah, do it. Take your time. Take your time. It's very easy. Just be calm, cool. You will happily do it.
Oh. 6, 3, 9.
Yeah, Charan, I'm waiting for your response.
Sir? Oh, yes, sir.
Yeah,
Like for the third iteration is like 4, 5, 2, 1, 6, 3, 7, 8, 9.
very good, Charan. Perfect. That's it, Charan. You see, this is a question for you in your exam. I've seen your question papers. They have given bubble sort. They wanted you to print it, like they wanted the output for third iteration or second iteration or first iteration. Okay. So
Okay,
that's
sir.
how easy it is. Understood bubble sort? Clear?
Yes, sir. Yes, sir.
You understood the concept?
Yes, understood, sir.
Code, we need to write it in Python and the comparisons will be the same. But first, I wanted you to understand the working of it because code will be very simple only and they are asking you to print the output of every, what you say, iteration. So this is 70% of your answer. And the 30%, you just need to know, okay, which line of code will do what, or you can even by heart it and write it in your, okay, what you say, exam, because no practical is there, only the written part. So that would be fine. That is about bubble sorts. And this process will keep on moving. I'll just click on next, 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 and all you see here. Okay. So 7, 1, 7 swapped, 7, 6, 6 swapped, 7, 3, 7 swapped. Now third iteration done, 7 is fixed. Now this process will keep on repeating, Sharan, until everything is sorted. You see, end of fourth iteration, 6 will be present at the last, right? Now,
Yes,
end of fifth iteration, 5 will be pushed to the last. Bigger bubble always floats to the top by comparing those adjacent elements. Okay, this is how it happens. You see, this keeps on happening. This keeps on happening. The procedure is same. You will start from the left side. You will start comparing two adjacent elements, and you will move the bigger element to the right side. And once you are done comparing everything, so one element will be sorted. And if you keep on repeating it, okay, you need to again come back to the front. You need to again start doing the same way. And if you keep on doing the same thing, you will have the entire list sorted. This is one way of sorting. Okay, so that is why we use the word algorithm. Algorithm is a way of solving. We have bubble sort. This is one way of solving. We have insertion sort. We will see that. Okay. Now, what I want you to do is revise the second unit, list, string, tuple, dictionary. I'll be asking you the methods in there, right? So, and bubble sort, I'll give you a list of 10 values or 5 values. I'll ask you to tell me the third iteration, fourth iteration, or I want you to write the end value in every iteration until it's sorted. So we have 9 elements. We will be having 8 iterations here. Output of first iteration, second iteration, third iteration, you need to write it. So revise bubble sort as well. We will see the coding part of bubble sort. Then I'll show you insertion sort. We will also discuss the, like what we say, coding part of insertion sort. Okay. Once you complete the revision part. Done? Clear, Charan?
yes, sir.
That's it. That's it, Charan. That's it for this small session. Then revise it. Once you are ready, prepared, just give me a message. I'll connect with you. Okay.
The test next class, right?
Hmm?
The test next class.
Yeah. Now only once like start reading it. If you are done with that, give me a small message. I'll get connected with you. We'll have that oral test. I'll ask you some questions. You need to answer them back. And if I think it's okay, you're fine. If you are lacking in any concept, I'll repeat that. So if you're answering everything perfectly in the first 5, 10 minutes, then we will continue with the next one, that is insertion sort we will see, bubble sort code we will see. Second chapter will be completed. Second chapter completion, I'll give you the test paper. Okay, there will be a proctor. They will be watching you. So completion of text, I'll give you some more time for relaxing. After the completion of your lunch, we will start third chapter. Okay,
Okay, sir.
done, Jaran?
Done, sir.
Fine, Jaran. So yeah, do some revision. Relax for 5 minutes a bit, then start revision. Once you're done, give me a call. So I'm expecting you to message me in either 1 or 1.5 hours. Okay, that's the
Or
maximum time it would take you. Okay. So I'll keep our codes and all in the chat, okay, in the WhatsApp group. So that's it, Charan. I'll see you again in 1 to 1.5 hours. Complete it and get back to me.
yes, sir.